Okay, this problem is coming out of the 7.2 homework. So what we want to do here is construct a truth table for this compound statement here. P implies Q or not P. Okay, so I'm going to rewrite this truth table over here because it's usually beneficial not to do this all in one step. So what we want to do is we want to build this compound statement one by one, one logical connective at a time. So we have a conditional, we have an if-then, we have a disjunction or an or, and we have a negation or a not. Okay, so we want to see what happens here. What happens to this guy, this compound statement, for every possible combination of trues and falses. So every combination of P and Q. So, okay, we say P and Q could both be true, P could be true and Q could be false, P could be false, Q could be true, or they can both be false. Okay, so rather than try to do three things at once, let's just go one logical connective at a time. So inside the parentheses there's a not P. Okay, so we're looking at only this column here, the not P column. So when P is true, not P must be false. And again, if P is true, not P is false. The third entry is a false, and when P is false, not P must be true. And then again, true. Okay. Still inside the parentheses, we have a disjunction. So Q, actually, you know what, let me change colors here. I'll use red to denote which logical connective we're using at each step. Okay, so we're doing Q or not P. So in this case, we're looking at the Q column, which is here, and we're looking at the not P column, which is here. So at every step, except for negation, which we're only looking at one column, every other logical connective, we're only ever looking at two columns. So the Q column or the not P column. Okay, so the first entry, we have true or not false. So true or not false by definition is true. Next we have false, false. So false or false equals false. Next we have true or true equals true. And finally false or true is true. Okay, and finally the last logical connective is the if-then. So we have P implies Q or not P. Okay, so we're looking at the P column first. So P implies the Q or not P. So that's this column here. Okay, so we have true implies true, and by the definition of the conditional, that equals true. True implies false. Again, according to the definition, that is false. False implies true. That's true. And false implies true again. That's true. So this, let's get rid of this and this. Okay, so this is what the truth table might look like if you're writing it out. This part here, this is just sort of scrap work. This is not part of the solution. This is your answer. This is what goes here. Those final truth values, once you have incorporated every logical connective that's part of that compound statement. In this case, there's 3 logical connectives, so we did it in 3 steps. All right, that's it for this one. I hope this helps.